We arrived to the second pitching session of the day. 6 speakers will come on stage, one after the other. They will have exactly 6 minutes. 3 minutes each, of course. They will provide us with showcases of BME's various research activities. Esztella Balla from the Turbomachinery Research Group, Miklós Horváth from the Department of Building Service Engineering and Process Engineering, Péter Nagy from the Department of Hydrodynamic Systems, Csaba Horváth from the Acoustics Research Group, Erika Mária Vági from the Department of Chemical and Environmental Process Engineering, and finally Tamás Kovácsházy from the Department of Measurement and Information Systems. The stage is yours, I guess.
The floor is yours, sorry.
Okay, thank you very much. So good morning, everyone. I'm Esztella Balla from the Department of Fluid Mechanics, and yes, in the upcoming 2.5 minutes, I will present to you our Turbomachinery Research Group. So our main research focus is on the development of the rotor blades of fans, let it be radial or axial fans. But besides that, we also deal with advanced fluid engineering systems as a whole. So this can include valves, ducts, and even pumps for incompressible flows. And during the design process, we aim for high performance, high efficiency, and low noise fans. And we are also meeting specific requirements like design for for dusty environment, for long throw fans, or even for very high specific flow rate. What methods are we using during our research? We are using numerical simulations, including aerodynamics and acoustics, and we also conduct measurements on a daily basis inside our lab or even through on-site industrial measurements. In our lab, we have measurement equipment for high-resolution flow mapping, for instance, constant temperature anemometry, particle image velocimetry, or laser Doppler anemometry. Next slide, please. So to sum it up, we do development in a comprehensive manner with a very strong relationship with industry. Major achievements are more than 100 high-quality scientific papers in the field of turbomachinery. In the past 10 years, more than 100 fluids engineering related industrial contracts and research grants, also in the past 10 years. And we very actively participate in the organization of international conferences. Just to name 2 upcoming conferences. One is the Conference on Modeling Fluid Flow this August, and Budapest will be hosting the European Turbomachinery Conference next April. Next slide, please. So we are interested in consortium memberships and hop-on projects. I just listed a few calls, open calls, which might interest us, like integrated wind farm control, digital solutions for hydropower operations, and smarter buildings for better energy performance. But I listed also the Horizon Europe keywords, and any of them might be of interest to us. Okay, next slide. And so if you would like to know more about us, then you can contact me through email or through the Huva app, or you can also contact our research group leader directly, Professor János Volt, at the following email address. Thank you.
Hello, everybody. I hope you can hear me. My name is Miklós Horváth. I'm presenting on behalf of the Energy and Buildings Research Group. I'm going to present 2 of our projects now. So next slide, please. Thank you. So the first project is the Quality EPC project, which is a Horizon 2020 project. Basically, the project has 7 goals, which are focusing on enhancing deep energy renovation for retrofitting buildings. And the first goal is to improve the quality of the energy performance certificates and also enhance deep energy renovation. We are developing an online tool for comparing EPC recommendations for building users and owners. Also, we are launching a deep renovation network platform where, let's say, the general public can gain more information on the renovation possibilities and what could be most suitable for their building. Also, there is a need for energy assessor training in order to be able to implement such measures. Next, please. The fifth goal is the high user friendliness of the EPC. So we are trying to be as much generally understandable as possible. So we propose a new EPC template, which I will show you on the next slide. However, also there's a need to enhance the advertising guidelines for the EPCs and also there to increase their value in real estate advertisements. Next slide, please. So here you can see the proposed EPC template. It's instead of a one-page template, it has 4 pages. The front page contains most of the current information on the building type, etc. It also contains the energy rating of the current state and also with the proposed renovation measures. So on the front page, you can see your possible savings. In the middle, you can see 2 pages, including detailed information of your building structures and HVAC systems, all with a rating, 5-point rating system, so people can better understand the structures, the structural elements, and the HVAC components of their building. And on the last page, there is a step-by-step implementation suggestion, and also it's sort of implementing the renovation passport prospect, and also further information can be found on the links provided. Next slide, please. And just briefly, I would like to introduce the other project called HiSmart. It's an Erasmus Plus project, and we have developed in cooperation with the University of Kaiserslautern and the Technical University of Bratislava. Training materials in order to train highly qualified experts and designers who are capable of design and operate net zero energy and smart buildings. Next slide, please. So thank you very much for your attention. Here you can see the projects and also link to our research group. Thank you very much.
I also would like to welcome everyone. My name is Péter Nagy. I'm member of the Flow Stability Research Group. We are at the Department of Hydrodynamic Systems at the Faculty of Mechanical Engineering. Next, please. First of all, I would like to introduce our research group. So the leader is György Pál, and I'm also the member of the research group, and there are 2 other PhD students. And next, please. And we cooperate with Martin van Eerschot, who is a professor at KU Leuven. And next, please, and Péter Rutz, who also works at our university, but at the Faculty of Electrical Engineering. Next, please. So why flow stability is important? Because it causes flow oscillations, and flow oscillation can induce significant noise. This is one of the main problems. It's sometimes useful, for example, in the case of wind instruments, but in many cases, for example, in the case of vehicles, it generates significant noise, which is also harmful for the passengers and also for the environment. Furthermore, flow oscillations usually leads to turbulence, so the flow becomes first unstable and turbulence develop. The problem with this that it will increase the drag. In the case of a streamlined body or vehicle, this increase can be 1 magnitude larger, which of course increases the fuel consumption, the energy need, and it has a very bad environmental impact. Next, please. So to investigate such a flows, our group has very strong mathematical background on this field. Next, please. And we have computational fluid dynamics experience, And we developed the MATLAB and FreeFAM code package for analyzing such kind of flows. And we achieved our major achievements with this code. We developed an elastic coating, which is able, according to theory, around 10-20% drag reduction. And we also developed a complete investigation methodology for another device which can prevent turbulence. This is miniature vortex generators. Furthermore, we have a quite accurate model to predicting flute instruments. Next, please. So, based on our capabilities, we are interested in cooperations. In the case of acoustics, we are interested in noise reduction application. In the case of the drag reduction, we want to improve the technology readiness level or solutions. And in the case of EU Horizon topics, we are interested in sustainable and clean transport and mobility. So thank you for your kind attention. And if you are interested in any cooperation, you can find here my contacts. Thank you very much.
Good morning. My name is Csaba Horváth, and I'm here on behalf of the Acoustics Research Group. I'm the head of the Acoustics Research Group here at the department, and our department of Fluid Mechanics, has many areas that we're skilled in. We have many skill sets and vast experience in many areas. You can see here on the left side that we have experience in environmental flows, internal flows, acoustics, and turbomachinery. We also have a vast amount of laboratories and other assets which we can use, such as our wind tunnels, which you can see on the top right here, and our acoustic anechoic chamber and reverberation rooms where we can carry out measurements, which you can see on the bottom right here in the pictures. Can I please have the next slide? And our research group carries out combined aerodynamic and aeroacoustic investigations in order to solve many vast series of problems. As you can see from our vast experience in many areas and our vast facilities, we're able to do this for many areas, and we're not confined to just one or two topics. So we're interested in many different types of investigations, and we'd love to help you out in those. We mostly develop and apply various measurement and simulation techniques in order to carry out these combined investigations. You can see here on the bottom left that we've done many different types of simulations, and we've also carried out many types of measurements, which you can see on the right. We mostly work together in a highly concentrated unison with the Turbomachinery research group, who you heard about before from Esztella, Balla. And we concentrate highly on turbomachinery, therefore, and we concentrate quite often on carrying out turbomachinery beamforming investigations. You might ask, what is beamforming? Well, on the right side here in the middle, you can see a phased array of microphones, which is a large number of microphones, which we process in order to trace back the sound waves to noise sources, which you can see on the lower right-hand side here. Can I please have the next slide? Our best known research so far has been together with NASA Glenn Research Center and Williams International in investigating turbofan engines, which you can see on the left. And our other one, which is rather known, is our collaboration with the GE and NASA Glenn Research Center in order to investigate counter-rotating open rotor engines, which you can see on the right here. Next slide, please. So our goal is to utilize our skills and assets in order to further develop clean and quiet technology as a member of an international collaboration. Therefore, we're looking for partners who need help with combined aerodynamic and aeroacoustic investigations. We'd like to help you out with that. There are many keywords which this can apply for, since these apply in many areas. I've just listed a few from the list of the Horizon Europe keywords here, but we're interested in many different topics. We'd love to help you. So if I could have the next slide, I'd like to thank you for having me, and this is my contact information. Thank you very much.
My name is Erika Vági, and I'm here to represent the High Pressure Research Group at the Department of Chemical and Environmental Process Engineering. Can I have the next? Our team leader is Professor Edith Székely, and we are working together with two very enthusiastic young researchers, Dr. Márton Körösi and János Péri, who is a PhD fellow. And we are working at the area of high pressure technologies using green solvents such as supercritical carbon dioxide and supercritical water, and using green technologies as well. Can I have the next slide? main focus on extraction and fractionalization using different techniques at lab scale and also at pilot scale.
I'm sorry for interrupting, Erika. Could you please talk to the microphone? Yeah.
Okay.
That's perfect.
Sorry. So we are mainly focused on extraction and fractionalization using different techniques at lab and pilot scales. We have a high pressure carbon dioxide extraction and separation unit, which can work up to 500 bar pressure. We can carry out pressurized liquid extraction, including subcritical water. Anti-solvent fractionalization unit we possess as well to produce different crystals, different size of crystals, and separate components. And we also possess the traditional extraction techniques units, such as the solvent extraction, steam distillation unit, and ultrasound assisted extraction. We are working very closely together with the industry and try to help them to solve their problems. Of course, we can provide technological solutions. We are very strongly doing optimization of the different process parameters and also modeling and simulation. Can I have the next slide, please? We are interested in all sorts of national and international research and development grants, and which are very much application-driven grants. We are involved in writing and also writing proposals for Horizon Europe and involving building a consortia. We have been led several national and international research programs already. Can I have the next slide, please? And you can find us at LinkedIn, ResearchGate, Facebook. You can also research our website. So thank you for your kind attention.
My name is Tamás Kovácsházy, and I would like to introduce the Heterogeneous Real-Time Distributed Embedded System Laboratory at the Faculty of Electrical Engineering and Informatics. Please, the next slide. Okay. I would like to introduce the title. Heterogeneous means a multi-core CPU architecture with CPUs, microcontrollers, FPGAs, and GPGPUs. Now you can find it on, let's say, single silicon chips, all of these systems, and you can build various processing systems for it to do AI and other interesting stuff in embedded systems. These functions must be implemented in real time because in some applications, safety critical applications, we must meet with strict deadlines for activities. If we do not do something in time, and typically it is in the range of milliseconds, some very bad things will happen, like your car will run from the road. These systems today are distributed, they are networked using Ethernet, Wi-Fi, and other communication technologies. And of course, these are embedded systems, dedicated systems for special purposes like automotive industry and stuff like that. Of course, our system must operate at low power and typically low cost. On the right side, you see such chip and some development system we use regularly. Next slide, please. I would like to talk about our Horizon projects. One of them is Smart for All. It is an innovation action project, and it provides open calls in a cascading type of funding. In this funding scheme, we have Hungarian winners. And if you have some spin-off company or something like around you, maybe you can also apply for this cascading funds. And this project operates a marketplace for collaboration and provides educational materials in the embedded system area. Or other project called Brainy, it is also a Horizon 2020 project, and it creates a configurable AI-centric edge server, which can you put to your industrial processes. It is configurable, it has various processing loads, and or my group develops an FPGA node and certain software component for this thing. On the right side, you can see the FPGA chip and let's say case and various boards, conceptual drawing of these in a 3D environment. And now these things are very close to final prototype stage. Next slide, please. What we are interested in, we have successful Horizon 2020 projects, and we are planning to apply for Horizon projects. we have experience in project writing and stuff like that. We are open also for the industrial research and development. We have several projects that I didn't have time to show you. And of course, we are active in education. We provide trainings for the industry also. Next slide, please. Thank you for your cooperation, for the audience and the patience to listen to us or to me. And you will find my contact information here. Thank you.
We just arrived to the new pitching session, or the next one of the day. There will be 4 presentations that you will see. Sándor Imre, Department of Network Systems and Services, will be the first one. Benjamin Csippa, Department of Hydrodynamic Systems, will be the second presenter. And the third is Bálint Csonka, Department of Transport Technology and Economics. And finally, Ákos Török, Department of Engineering, Geology and Geotechnics. We will move the slides forward so you don't have to worry about them.
Okay, thank you very much. So my name is Sándor Imre. I am working for the Department of Network Systems and Services for the Faculty of Electrical Engineering and Informatics. Please, next slide. We have a team, roughly 20 staff members and PhD students who are working on the field of quantum computing and communications. Next slide, please. Okay, so the major topic of our team and research group is, on one hand, quantum computing algorithms, especially quantum optimization used for engineering problems. Furthermore, we have expertise in quantum communications. On one hand, fiber-based, so wired quantum communication links and networks. And on the other hand, we have solutions for three-space quantum communications. Finally, because real random numbers are quite important for cryptography applications, we developed our own quantum random number generators. Furthermore, we are responsible for the organization or handling the team, which is responsible for the deployment of national Hungarian quantum key distribution network. So we had a successful experiment and test this May between the Budapest University of Technology and the Wigner Institute of Physics. So we have our own developed quantum key distribution network for fibers. On the other hand, we are planning our three-space experiment this September between BME and Vodafone premises. Next slide, please. Okay, so we are strongly interested in any programs and cooperations which are related to quantum technologies, but within the quantum technologies, we are experts on the field of communications and computing. We are cooperating with physicists who are very well skilled in quantum optics and with mathematicians who are responsible for quantum information theory and this type of aspects. And we have a very strong high-level security laboratory at the department. They are focusing on the classical aspects, and together with them, we are very good in any security solutions. So we are interested in collaborations, even in bilateral R&D projects or EU Horizon program as well. And we offer professional consulting services for any companies who are interested. So thank you very much. You can find my contact information here.
Thank you. Welcome, everyone. My name is Benjamin Csippa from the Department of Hydrodynamic Systems from the Faculty of Mechanical Engineering. And I would like to introduce our research group called HDS HemoLab that is led by Professor György Pál. Next slide, please. Thank you. So currently, our group includes 6 people, 3 PhD students, 2 research fellows, and an assistant professor. And our group studies blood flow dynamics, aka hemodynamics, using computational and experimental tools, mainly computational tools. And we have an in-house one-dimensional so-called FSI code for arterial network simulations. And we conclude 3-dimensional simulations for all kinds of arterial diseases, be it commercial, like ANSYS or open source, and of course in-house codes for these numerical simulations. Also, we have an ample lab space available to set up experiments with laser Doppler symmetry, and we have a physiological pump setup that we can use to generate accurate heart rate waveforms for flow phantoms, such as the one that you can see on the right. Next slide, please. Our major achievement, perhaps, is developing a computational tool, a computational and experimental framework for the virtual treatment solution of intracranial aneurysms, one of the most severe diseases that can occur in the brain arteries. Such a simulation can be seen on the left, demonstrating the treatment itself when a flow diverter's effect can be seen on the flow field, if the video was right, if I'm correct. And because of this technology, we are included in the In Silico World H2020 project with 14 consortium members, with all kinds of partners from the academics to the industry. The project's primary goal is to lower the barriers, both in numerical tools and both legislative tools, to lower the barriers to the universal adoption of these in silico trials, which could help medicines and medical devices reach the market faster, cheaper, and most importantly, with decreased amount of human and animal testing. Next slide, please. And we are interested in collaborations that is in the digital health technologies, including the computational modeling and experimental analysis of blood flow dynamics. And we are keen to be partners in consortiums in the Horizon Europe cause as well. And we are reaching out to Hungarian and, of course, international medical partners for other grants and possible collaborations. And thank you for your attention. These are my contact informations.
Hello, everyone. My name is Balla from the Electromobility Research Group. First, I would like to thank you for this great opportunity so we can present our research group. Next slide, please. Our research team has a diverse experience and expertise in various fields. As you can see, we have a lot of members from the lower levels, PhD students and MSc students, to the higher levels, 2 members with a PhD degree and 1 member with a DSc and habilitation. Our research group focuses on the operation of electric vehicles. So we elaborate methods and solutions to support the use of these vehicles. Next slide, please. Our main research topic was the deployment of charging infrastructure, planning of charging infrastructure that we have elaborated both for private cars and for electric buses. In the first case, the main challenge was to find those constraints that the use of private cars can accept. So we divided the task into 2 sections: charging infrastructure along highways and in urban areas. Along highways, we used an approach where the data about traffic volume was needed, which is a novelty, and the oil stain approach to cover the whole country. And in the urban area, on the urban level, we focused on macro and meso level and on the parking. And in the case of electric bus service optimization, we combined charging infrastructure, bus fleet, and bus service optimization on the network level, which is the main novelty of our approach. At the below, you may see the projects that and the partners that funded our research. Next slide, please. Our activities include total cost analysis of private electric cars. Here we elaborate a cost analysis method to support the decision making of car users who are just before the purchase of a new electric car. This project was elaborated in a cooperation with the Hungarian National Bank. We also analyzed the electric car use behavior. Here we submitted a project proposal in collaboration with university partners from Morocco. We also evaluate the charging planning, how the charging can be planned to mitigate the negative drawbacks of car charging on the power network. We also submitted a project proposal in this aspect, and we also analyzed the energy consumption. Here we do this research with university partners from China. Next slide, please. And our team need to learn about more stochastic modeling, electricity networks, social sciences, and legislation. So if you are interested in this topic, you are welcome. And we are looking for collaboration in research project and project proposal developments, such as OTCA and Horizon. Thank you for your...
Hello, good morning, everybody. My name is Esztella. I'm representing Department of Engineering, Geology and Geotechnics, which belongs to Faculty of Civil Engineering. And our focus area is engineering, geology and geotechnics. And we have various fields in terms of this area. Next slide, please. Our department has a long history. It's nearly 160 years old. And we have a very old building stone collection. Actually, it is the oldest in Hungary. You can see on the right-hand side of the slides. And in terms of human resources, we have 42 members, staff members, including civil engineers, geologists, chemists, and also restorers. And we have a technical staff. And currently, we have 25 PhD students representing various countries. Next slide, please. Our main field of research is related to soil and rock testing laboratory, which is an accredited system according to European norms and American standards. Soil identification, various soil mechanical tests, including dynamic triaxial test, non-destructive testing of soil and rock types, ultrasonic pulse wave velocity testing. And we have a strong rock mechanics laboratory with various tools, tensile strength test, compressive and triaxial strength test. And we are also qualified to measure and discuss the aggregate tests and also qualify aggregates. We have climate chambers and salt crystallization facilities, and we have also a furnace. Next slide, please. We have various fields of research, including geotechnics like foundation engineering, slope stability, but also rock mechanics, tunnels, metro, and radioactive waste disposal, as well as environmental site surveys. We are interested in geothermics and reservoir characterization, as well as we have projects in monument diagnosis. So we have a broad field, and we are open to collaborate in any of these fields or any additional geological field. Next slide, please. And we have additional special skills, including 3D computer modeling with FEM, EM models, and in engineering, geology, and geotechnics. On these slides, what you can see a radioactive waste disposal site of Hungary. And actually the tunnel and the wedge failures of the tunnel was modeled using 3D model. And the last slide, please. And we have major international projects funded by the European Union, including Meranet, FAR, COST, etc. So the next slide, please. We are happy to collaborate to any of you, and please find our details here in the last slide. Thank you very much for your attention. Thank you very much. Bye-bye.